Namaskaram. In last session, we have seen that chain rule of multivariable function. In this session, we will see more problems and related formulas. Okay, so these are the solutions of last homework. Okay, consider this problem. Suppose that w equal to xy plus yz and y is equal to sin x, z is equal to e raised to x. We have to find dw by dx. And it is clear that our w depends x, y, and z, right? W depends x, y, and z. And what about y? Y depends x and z. Z also depends x. Okay. So this is the graphical representation of our this problem. This is a relation. So w depends x, y, z, and y and z depends x. Okay. So now it is easy to differentiate along these paths. Then how to find dw by dx? We have to differentiate w with respect to x along this direction plus along this direction plus along this direction. Okay, so what's the formula of dw by dx? Yes, dw by dx is equal to, this is dot w by dot x plus dot w by dot y into dy by dx plus dot w by dot z into dz by dx. Okay, then it is clear that what is dot w by dot x? It is nothing, y. Clear. And similarly dot w by dot y is x plus z, and dy by dx, that is cos x, plus dot w by dot z, that dot w by dot z is a y into e raised to x, right? Now now we have dw by dx, but we have to convert everything in terms of x. It is possible because we can write w in terms of x, so you can also find derivative in terms of x. Okay, so next you have to convert everything in terms of x. So you have to replace y and z by corresponding relation of x. Okay, so this become, yes, so this become sin x plus e raised to x. Z is e raised to x, right? Cos x plus sin x. What is y? Y is sin x e raised to x. Okay, so this is the final answer. You can also find, you can also convert w in terms of x using these relations. Then you can differentiate. Okay, that's also possible. But in general, this method is not easy, because in some situation this is very complicated expression, or so the evaluation of derivative from this type of relation is almost impossible. Okay. Okay, consider next problem. Z is equal to a function f of x minus y comma y minus x. That means z is a function of x minus y and y minus x. Then we have to find this sum of these two partial derivatives. Okay, so this okay, f is an arbitrary function. For example, z is equal to x minus y whole square plus sine of y minus x. This is an example of such function. There are infinitely many such functions. Okay, we have to find this sum of such all functions. Okay, so we are going to differentiate this expression directly. Okay, this is one example of such function. That's all. So first we have to draw the graphical representation of these dependencies. So how to plot? Let it be z is equal to f of uv. And what is u? U equal to x minus y, and v is equal to y minus x. Now you can easily find the relation, or you can easily draw the relation. How? Yes, z depends two variables, that is u and v, and it is clear that u and v depends x and y, right? U and v depends x and y. So now it is clear. You can differentiate. You have to find dou z by dou x. So you differentiate along this leg, plus you differentiate along this leg to find the dou z by dou x. Similarly, you can find dou z by dou y. Okay. So what's the formula? Dou z by dou x is equal to dou z by dou u into dou u by dou x, because u depends two variables. That's why dou u by dou x instead of du by dx, plus dou z by dou v, this root, this leg, into dou u by dou x. So next you have to find all these derivatives and substitute. That's all. Okay, here function is unknown, so you can take dou z by dou u as dou z by dou u into what is dou u by dou x. That is okay. That is 1. plus dou z by dou v into what is dou v by dou x? Dou v by dou x is minus 1. Okay. So this expression becomes dou z by dou x minus dou z by dou v. Similarly, you can find dou z by dou y. Okay, sorry, this is not dou u by dou x, this is dou u by dou z by dou u. Right, this is dou z by dou u. Okay, so this become dou z by dou u into dou u by dou x plus dou z by dou v into dou u by dou y. And we know dou u by dou y, that is minus 1. And dou v by dou y is 1. Okay, so this is our expression. So we have to find sum of these two. It means you have to take the sum. So what happened? You can cancel dou z by dou v and dou z by dou v. And this dou z by dou v, this is minus dou z by dou v. But ultimately sum is 0. Right? So this sum equal to 0. Whatever be the function of this type, always this sum is 0. Right? Okay, next we are going to discuss implicit differentiation in chain rule. So before that, we consider this example. Okay, here z depends two variables x and y. Then we know how to differentiate this expression, right? Because again, y is a differentiable function of x. That means y depends x. So ultimately, z is a function of x. So we can differentiate z with respect to x. How? First you differentiate along this path plus then you differentiate along this leg. So that's why dz by dx is equal to, okay, you can treat z or f whatever, no problem. Dou f by dou x, that means you differentiate along this curve, this leg plus dou f by dou y into dy by dx, right? So this is the idea. Okay, here the relation is explicit, z is in terms of x. Next we consider an implicit relation. Okay, suppose we consider equation like this, f of xy equal to z. Okay, maybe this relation is implicit, right? Defines y implicitly as a function of x. Then how to find dy by dx? So first we actually we are going to differentiate this equation on both sides. So whatever the left hand side is similar to this one. A function f depends x and y is again a function of x. Y is again a function of x. So left side is like this. Equal to what? What about the right hand side? Right hand side contains only c. It's a constant. So what is the derivative of c with respect to x? That is 0. Okay. By solving this expression, you can find dy by dx. What is dy by dx? This implies dou f by dou y into dy by dx is equal to minus dou f by dou x, right? So dy by dx is equal to minus dou f by dou x divided by dou f by dou y. Clear? So you can use this ready-made formula finding dy by dx if the relation is implicit. Okay. For example, consider x cube plus y square x minus 3 equal to 0. We have to find dy by dx. Okay, using using formula and implicit differentiation. Okay, this is for only the verification of this formula, right? Anyway, first we have to use that formula. What is the formula of dy by dx? Okay, what is our function? Okay, in our previous result, we have seen that the function is of the form f of xy equal to z, right? So you can convert here this function as like this: x cube plus y square x is equal to 3. So what is our fxy? So f is nothing, x cube plus y square x. And you can write the formula and evaluate the derivative. Okay. Okay, this is the formula of evaluating dy by dx. Then you can easily find dou f by dou x. What is dou f by dou x? 3x square plus y square. Okay. Similarly, what is dou f by dou y? That is 2yx. That's all. Okay. Next, we are going to verify this result by differentiating directly this expression using implicit differentiation. Okay, so this is our given relation. So we are going to differentiate this expression directly with respect to x. So this become 3x square, and here y is a function of x, and this is also a function of x. So this is a product of two functions. So we have to use the product rule. How? First function is y square into derivative of second function, that is 1, plus x into derivative of first one, that is 2y into again dy by dx. because y depends x. Clear? And derivative of 3 is 0, that is equal to 0. By solving this equation, we will get the same answer. Please verify. Okay. Anyway, this is our answer. Okay. Next we consider three variable case. Suppose f of x, y, z equal to c defines z implicitly as a function of x. Okay. That means what? Sorry, implicitly function of x and y. That means what? Ultimately, z is a function of xy, right? That means either x and y are independent, z is dependent. So here, sorry, okay, this is our f. So f depends actually three variables x, y, and z. Here x and y are independent, and z depends x and y. Okay. So how to differentiate this expression on both sides? So left hand side become, we have to suppose we differentiate with respect to x. So what about the left hand side? Left hand side is dou f by dou x plus, actually in this leg there is no dependency. Okay, if you differentiate, what happens? If you differentiate, this become dou f by dou y into dy by dx, and this term is 0. So actually this term is actually 0, right? Because there is no dependency with respect to x. Anyway, plus what about the last leg? We have one more leg which depends x. So that means dou f by dou z into, oh sorry, dou z by dou x, because z depends two variables, right? So this is the derivative of left hand side. And right hand side it is 0. Okay, so this expression is 0. So you can solve for dou z by dou x. What is dou z by dou x? Ultimately z depends x, right? Ultimately z is in terms of x. And this is the graphical representation of this relation. And this is equal to, we can take this term is to right side. So this become minus of dou f by dou x and divided by this term, that is dou f by dou z. That is this formula. So dou z by dou x is equal to minus of dou f by dou x by dou f by dou z. Similarly, you can find dou z by dou y. Okay, only difference is if you differentiate this expression with respect to y, then this term, this leg is 0. The derivative along this direction is 0. So we have only two terms. Then pairing to 0, then solve it. Okay, anyway, these are the two formulas for evaluating dou z by dou x and dou z by dou y if the relation is implicit. If z is defined implicitly in terms of x and y. Okay, let's see an example. Okay, consider this problem. We have to okay, a surface is given. Actually here z depends x and y implicitly, right? And we have to find dou z by dou x and dou z by dou y at this point. So we are going to find dou z by dou x and dou z by dou y using this formula. Okay. Okay, here the relation is f of x y z equal to c. So what is our f of x y z in this problem? Yes, it is x square plus y square plus z square. So first of all, we have to find dou z by dou x. To find dou z by dou x, we have to find dou f by dou x and dou f by dou z. And what is dou f by dou x? Yes, that is 2x. And what is dou f by dou z? That is 2z. Right. So just substitute these two values on this formula. Let's give dou z by dou x. So what is dou z by dou x? So minus dou f by dou x. Dou f by dou x is 2x by dou f by dou z is 2z. So you can cancel these two. So this is minus x. Right. So this is the derivative dou f by dou x. So dou z by dou x equal to minus x by z. Similarly, you can find dou z by dou y. That is minus dou f by dou y by dou f by dou z. That is minus 2y by 2z. So that is minus y by z. Okay, now we have two formulas. Next, we have to compute these two derivatives at this point. So you just substitute the values, right? So what about dou z by dou x at this point 2 by 3, 1 by 3, 2 by 3. So that is equal to minus 1. And dou z by dou y at this point is minus this y. So what is y value? Y value is 1 by 3. So minus of 1 by 3 by 2 by 3, that is equal to minus 1 by 2. Okay. Yes, one is minus 1, other is minus 1 by 2. That's all. Okay, this is your homework. Thank you.